Good morning. Today we will discuss some of the terms of a GP. Let S n denote the sum of n terms of the GP. Sn equal to a plus ar square up to n term, where a r power n minus 1 is the last term of given GP, where a is first term, ar second term, ar square third term, and last term is ar power n minus 1. And before last term, one term is ar power n minus 1. We can make equation number 1. Now multiply by r in the given sequence. We can write r into Sn equal to, we can leave first term. We will show the multiplication by r from second. Multiply by r in a, ar multiply by r, ar square up to ar power n minus 1, and before this we can write one term a into r power n. If I will write this term, if I will multiply by r in this term, r power n minus 2 plus 1 equal to r power n minus 1. Multiplied by r in this term, a into r power n minus 1 plus 1, we have r power n. Now we can subtract equation 2 from equation 1. Minus, 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 here and here. Now you can see these terms are removed. Only first term and last term we have. We can write here Sn minus r Sn equal to a minus ar power n. We have only these terms. Now we can simplify the given term here. Taking Sn as common, we can write 1 minus r into Sn equal to, taking a as common, 1 minus r power n, where Sn equal to a into 1 minus r upon 1 minus r. This is known as sum of n term of a GP. We can take r as common or minus 1. We can multiply by minus 1 in numerator and denominator. Then Sn equal to a into r power n minus 1 upon r minus 1. We have these two forms. When r greater than 0, we have to use this formula. When r greater than 1, when r greater than 1, we have to use. When r less than 1, we can apply this formula. Now see again, we have n terms in GP, and Sn is denoted by the sum of given terms. Then Sn equal to a plus ar square up to last term. We can make this is equation number 1. Multiplying by r in equation 1, we can write r into Sn. First step we can leave, multiply by r in first term, we can write here ar square up to last term ar power n. Subtracting equation 2 from 1, we have Sn minus r Sn, first term and last term we have. After simplification, this is a, this is a. After simplification, we have Sn equal to a into 1 minus r power n upon 1 minus r, where r not equal to 0. R not equal to 0. In this formula, r never be 0, but r less than 1, we can use this formula. When r greater than 1, we have to use this formula. This formula known as sum of finite term in GP up to n terms. We have two forms of sum of the terms in GP. First is Sn equal to a bracket 1 minus r power n upon 1 minus r when r less than 0, r not equal to 0. And second is Sn a into r power n minus 1 upon r minus 1 when r is greater than 0. We can write here r greater than 1. Greater than 1. We can write the given formula multiplying by a. We have multiplied by a in the given bracket a into 1 minus r power n. But the formula for last term in GP we have r l equal to a into r power n minus 1. We can make the formula for the sum in GP for last term. Sn equal to a minus a into r power n. We can write here, we can add one value and multiply by r. This value power is 1. 1 plus 1 minus 0. No change there. But this value can be written as L. So we can write here 1 minus r. Sn equal to a minus L into r upon 1 minus r is the sum formula when last term is given. We can use here L equal to a into r power n minus 1. 1 r added, 1 r power subtracted. We can write here r power 0 and 0 equal to 1 minus 1 plus. This value equal to L. We can multiply by r. This formula we can apply when last term is given and common ratio given. Similarly, we can change this form also when last term is given. To solve the sum of 7 terms of the GP 3, 6, 12 and up to n terms, we can apply here the sum formula for GP where first term is 3 equal to 3, r equal to 6 by 3 equal to 2. We have to find out the sum of 7 terms. We know that sum of GP when r is greater than 2. Now you can write here r equal to 2 greater than 1. We have to apply here a r power n minus 1 upon r minus 1. This formula we have to use here. Now we can substitute the values of a and r. N equal to 7. We can write here 7. First term is 3. Common ratio is 2. 2 power 7 minus 1 upon 2 minus 1. Sn equal to 3 into 2 power 7 minus 1. 2 minus 1. Now we can leave here. This is answer. Now we will discuss more question to understand how we can apply the sum formula for GP for nth term. Now we will find the sum of GP in the form of 0.7 plus 0.77 plus 0.77 up to n terms. Now we can write the sum of given GP is S. So we can write that S equal to, this is S equal to 7 plus 0.7. Now we can write S equal to 7 by 10 plus 77 upon 100 plus 777 upon 1000 up to n terms. Up to n terms. Sum of given GP S equal to 7 by 10 plus 77 by 100 plus 777 upon 1000. We can take 7 as common. 1 upon 100 plus 1 upon 1000 up to n terms. N terms we can write multiplying by 9 and divide by 9. We can write a given sum as equal to 7 by 9, 9 by 10 plus 99 by 100 and up to last term. Now we have multiplied by 9 in numerator and denominator. We have taken 7 as common from the given series. If we have taken 7 common, here 1 by 10, 7 common from 77, 11 by 100, 7 common, we have 100, 11 upon 1000. Multiplying by 9 and divide by 9. We are trying to make two different GP. Multiplying by 9 and divide by 9. Here 9 can be written in the form of 10 minus 1. 99, this 99 can be written in the form of 100 minus 1. And 999 equal to 1000 minus 1. Now we can divide by 10 to the numerator. We can write 7 by 9. 1 minus 1 by 10. Similarly, next one we can write plus 1 minus 1 by 100 plus third term is 1 minus 1 by 1000 up to n terms. Up to n terms. Taking first term from the sequence, we can make a GP 7 by 9, 1 plus 1 plus 1 up to n terms. These terms we have taken first term of the given sequence minus second term we have up to n terms. Up to n terms. 1 plus 1 up to n terms. The sum of GP when terms, first term is 1, second term also 1 and third term also same. Up to n terms. Now we can apply here some formula for GP. I will show you some. We have two GP up to n terms. First term 1, second term also 1. Here first term is 1 by 10. 1 by 10 is less than 1. So we have to use second formula for sum a into 1 minus r power n upon 1 minus r. To find the sum of given GP up to n terms, we can write Sn equal to a into r power n minus 1 upon r minus 1. But for this series, for this GP, we have to use second formula. We can write here the sum of this GP is n and sum of second GP, where first term is 1 upon 10 minus r equal to 1 upon 10 power 10, 1 minus r power n. I am writing here which formula we have used. 1 minus r. Because r is less than 1, r less than 1, we can substitute here a equal to 1 by 10 and r equal to 1 by 10. Then we have, now we can simplify 7 by 9 and minus 1 by 10 minus 1 upon 10 power n upon 9 by 10. We can remove this value. Next step we have 7 by 9 and minus 1 by 9, 1 minus 1 upon 10 power n is the sum of given GP. First of all, try to make two different GP up to n terms and use the formula for the GP.